All right, now in the store, in our root reducer, here we're returning the new state. Now this state is very simple. Here we have only one property, counter. But what if we had 10 other properties? We don't want to repeat all these properties here. So what I mean is, in this new object, we don't want to add something like prop1 and set it to state.prop1. And then prop2, set it to state.prop2. It's very tedious. So I'm going to show you two ways to make a copy of the state object and apply mutations on the fly. So in JavaScript, if you want to take a copy of an object, we can use object.assign. So here, we can call object.assign. With this method, we can combine multiple objects into one object. So if my target object is just an empty object, and my source object is this state object that we get in the root reducer, now I can combine this state object with another object. Now, if the property names are the same, the values will be picked from this object here. So with this, I can take all properties of the state object and apply a mutation using this third argument here. So here we can set counter to state.counter plus 1. With this, all properties of the state, along with this counter, will be combined and placed into this first object here. And then we get the result and we return it to the color of the reducer. So this is the approach that you see a lot in tutorials about Redux. Now there is a tiny problem with this approach. Let me show you. So here in our third argument, I can add a property that does not exist in the state. So I can add something like is online and set it to true. Now our state is of type IAppState. So earlier we declared this interface here, and I told you that this determines the shape of our store. So technically, we shouldn't have any properties in the store that we haven't declared here. Now with object.assign, I can break this rule and add a property here that is not part of our interface. So for this reason, someone has implemented a type-safe version of object.assign that we can install via npm. So npm install tassign save. All right, now back in the store, on the top, I'm going to import tassign function from tassign module. And then we can replace this with something like this. Return tassign. We give our source object, which is this state object. Add the mutations here. So counter is state.counter plus 1. Now with this, I cannot add a property here that does not belong in the state object. So if I add is online and set it to true, look, we get a red underline here. Because this tassign function looks at all the properties defined in this state object, and if we add something here that does not exist in the state, it will complain. So it's more type safe. Also, I prefer the signature of this function because here we have only two arguments, the source object and the mutations. Whereas with object.assign, we have three arguments. First, we have to give it a blank target object, which is used for copying all the key value pairs. And then we have to give it multiple source objects. So personally, I'm not a fan of object.assign, but I decided to include it in this lecture because you see a lot of examples on the internet. So delete, delete, and remove the comment. And now let's get rid of this property. All right, so here's our root reducer. All right, there is still one more problem in this reducer. Earlier, I told you that we should not mutate this source state object here. And that's why we are using tassign to get a copy of that state and apply the mutations. However, there is nothing here that will stop me from writing code like this, state.counter++. So I'm mutating the source object, and this can create bugs in your application when using Redux. Now, there are two ways to prevent this. One is to write unit tests. So for every action you're going to handle, you write two tests. One to ensure that the source state is not modified, and the other to ensure that the state that the reducer returns has the right values. So writing unit tests is one way. The other approach is to use immutable objects, and that's the topic for the next lecture.